Hey guys, I'm going to be going over the balancing chemical equations notes that we did in class today. So if you had any trouble with them after our class today, I know some of our classes had some technical issues, or if you were not able to attend class, this is for you. So first, we're going to be looking at the notes here. They should look like this. You can find them in the, let me get to the folder, the Balancing Chemical Equations remote folder right here, and then click on the intro to Balancing Equations notes. When you click on that, you'll see that there is a link here, the intro to balancing slides. This will take you to the slides that I'm going to be reviewing. After I'm done with this video, below here, I'm going to post this video. So that's how you can find it and watch through it. Hopefully it'll be able to help you out. So we're going to be starting here. This is also for both the general and the double A classes as well. So the only difference in the notes is towards the end, and I'll make sure and make that differentiation when we get there. So first off to start, remember you're filling in the highlighted boxes with the matching boxes in your notes. So what is a chemical reaction is where we're starting. And by the end, we're going to be able to balance chemical equations and define the law of conservation of matter. So uh, what is a chemical reaction is where we're going to start at. Reactions occur when two or more atoms or molecules or compounds interact and then rearrange their composition. So this happens when atoms come together, like you can see in the picture at the bottom, and they interact with each other. Sometimes they need a kick of energy, like a spark or some electricity to interact and make this happen. When they do that, they rearrange their atoms and form new atoms or new molecules. So bonds between these atoms are broken or created to form new molecules. So you can break atoms bonds here. So like I'm going to be using this water one a lot. So you have H2 at the bottom and O2. When they combine, they break their bonds with each other and bond to the other atom. So you can see the green hydrogens bonded to the red oxygens. So they broke a bond and then created a new bond, which created something new. So that is what a chemical reaction is at the heart. So we symbolize these chemical reactions by using equations. So it's a written representation of a chemical reaction using the symbols we learned in class. So you guys might have been asking, man, why are we learning this periodic table stuff? This is why. So this is like the high functioning like application of what we've been going over for the past, I don't know, 3-4 months. So Ag plus H2S yields or makes Ag2S and H2. So a couple things we need to know about this is Ag is the periodic table symbol for silver. H2S is the symbol for the compound dihydrogen monosulfide. Now, if you think that is a lot to say, it is. And the regular name they use for that is sulfuric acid. So a lot of times chemists have short names or what we say common names for different compounds just to make saying them easier, which is all the more reason that we need to understand why we use these chemical equations and symbols instead of trying to figure out the names. So it's really only for if it's spoken out loud. So that makes silver sulfide and hydrogen gas. Anytime you see a nonmetal like hydrogen with a 2 subscript, that means it's a gas. So it'd just be like hydrogen gas, like you'd find in a tube. So in these reactions, you have reactants and products, which you're going to get to on the next slide. Reactants are the chemicals you start with before the reaction. So it's the stuff you mix together in order to create something new. The part of the equation that the arrow points away from are the reactants, and that's key. Sometimes the arrow points in different directions. The majority of the time, I'm going to tell you it's going to be on the right, but there are some times where it's on the left. But I want you to understand that the products are what's produced, and that's where the arrow points to. It's the new chemical that's formed in this reaction. So it's where the arrow points to. Sometimes that can be to the left, sometimes that can be to the right. Most of the time it's to the right, but there are times where it is to the left. So I want you guys to understand that it could be either way. And here is a couple examples of that. So first, you can make water. H2, which is hydrogen gas, remember the two, plus O2, which is oxygen gas. Together, they make water. All right, and that's the liquid form. So two gases make a liquid. Here's that chemical reaction.
When the two gases are mixed, a spark will cause them to react. The atoms explosively combine as a pair of electrons become shared between each oxygen and two hydrogen atoms. A closer inspection of the inside of the container shows water vapor condensed on the cool container walls.
All right, so you can see here that the water doesn't come like gushing out like it would a faucet, but you can see the little water droplets on the inside. And this is how you chemically make water. Now, this process is inefficient and not what we use to get water regularly, but you can produce water in a bottle. It's possible. Seems like magic, but it's possible. Now, you can do this the opposite way. You can also break down water into its parts. And you can do this with a lot of different chemicals. So notice that the arrow is now pointing to the left, meaning that the product is hydrogen gas and oxygen gas. And the thing doing the reactant is the water. So this happens sometimes in the presence of a specific type of energy will cause the atom or the compound to break apart. And this is called decomposition, like you would decompose, like stuff decomposes if you leave it outside. And this is what happened. You can do this one at home. So in this one, I'm going to I'm going to pick where I want to go. So he's got a battery on the bottom here, and he's got two pins sticking through. So when you touch the pins, the electricity begins to flow through the water and adds energy to the water, which breaks the bonds of hydrogen and oxygen. And you can see them flowing up the test tube. All those little bubbles, that's gas. And you can see that the gases are gathering at the top and it's pushing the water out the bottom. So this is something you can do at home. Hopefully we get a chance to do this in the classroom. And this is a process called electrolysis if you want to look it up. So if you drop a 9-volt battery in a cup of water, you'll see bubbles because there is a chemical reaction going on that's separating the oxygen from the hydrogen. So let's check in on our notes. All right, we should be down here. So far, I've covered this. So next we're going to talk about coefficients. So these chemical equations have different parts to them. You have subscripts and you have coefficients. We've talked about these before. Subscripts are the small numbers that are underneath each element. So you could have H2, meaning hydrogen has 2 and oxygen has 1. So right here, if there's no subscript, that just means that it is a 1. No subscript equals a 1. So here you have 2 atoms of hydrogen and 1 of oxygen. Now, coefficients, this is what we're going to be spending a lot of our time on. We can change these. You can change the coefficient, and you can change it frequently. So what you can do is change the coefficient in front of it to equal or to multiply this out. So you can have 3 water molecules, not 3 H2O, which means there's also 6 hydrogens and 3 oxygens. All right, so I'm going to go over to your notes now. So in your notes, you should see this. When you double click on the picture, you can drag each one to where they go. So remember, the coefficients are what go in front. So if I drag and the subscripts are what go below. So if I drag these to the correct spots to label this diagram. Coefficients go in front, subscripts go below. Save and close. Should look like that. All right. Next up, we have the law of conservation. So the law of conservation says that chemicals cannot be created or destroyed. And what that means is you can't just randomly snap your fingers and have something in your hand. So you can't snap your fingers and have water appear in your hand. It's not how it works. That would be creating matter that wasn't there before. And you can't destroy it either. So you can't when you burn a piece of paper, if you wrote your name on it, you or like some secret you wanted to keep, you're destroying the secret, like the idea that the paper held a secret, but you're just rearranging the chemical matter of the paper into gas and light and heat. So it's not being destroyed, it's just being rearranged into something you can't read. So this whole creation and destruction of matter used to be a huge thing called alchemy, and a long, long time ago, they used to think you could produce things like gold out of average things like, I don't know, a potato, and that was the holy grail of chemistry at the time, was to try to produce gold from non-gold objects. But this law of conservation says that that is impossible because you cannot create something that wasn't there to begin with. So since this is a true law, I remember we talked about laws are things that are always true. When these chemical equations follow this rule, it's considered to be balanced. Now, this term balance, we're going to use a ton, and we're going to get really good at this. And the whole point of me teaching you how to balance equations is to prepare you for chemistry and biology next year so that you can succeed there. Again, my vision for this class is to give you the preparation for the sciences you're going to take later in high school. So, first, an unbalanced equation looks like this. It is when the amounts of atoms on the reactants is not the same as the products. So this is called the T-chart I drew, those black lines. What it does is it separates the reactants and the products from each other, and you do a drop-down line right at the arrow. And this is just a graphic organizer. It just organizes the picture in front of you. It's not anything special. It's not a chemistry trick. It's literally just to help you organize. And I encourage you guys, when you go through this stuff, to take your brains out of chemistry mode and treat these problems like they're or like number puzzles. Okay, so don't worry about like what CH4 is. All right, just understand that you want them to be equal on both sides of the equation. All right, we'll get to that in a minute. So you can see that one carbon atom is in black, 4 hydrogen atoms are in green, and 2 hydrogen atoms are in red on the reactant side. But on the product side, you have one carbon atom, so far so good, but only 2 hydrogen atoms, which does not equal 4. So if this equation were to be true, this would be saying that you just randomly lost 2 hydrogen atoms, just out there in the universe, just disappeared. It doesn't work. That's not how this works. So that's why we have to balance this equation so that there's equal amounts on both sides. So you can also see that there are 3 oxygen atoms. You have 2 bonded to the carbon and you have 1 bonded to the oxygen. Now that's important to note because when you do this, you're going to need to do the total number on that side of the reaction, not just because it's bonded separately. All right. And the whole reason we balance is to understand how much of a product will be made in a reaction. And this is what the whole pharmacy, what's I'm looking for, industry is based on. All right, you can take things, rearrange them into chemicals or pills or drugs, and sell them. You can be like, how much stuff do I need to make um, combined together to make Tylenol and stuff like that. So they need to know how to balance these equations to know how much product will be produced. All right, so here is a T-chart. All right, and what I'm going to do here is it's going to match your notes. So in your notes here, is where we're going to be at. So let me delete these real quick. So an unbalanced equation, we did that. So I'm going to be tackling this question right here. Is this equation balanced? So in our notes here, a T-chart looks like this with the product and the reactants. So, all right, now again, forgive me if this doesn't look super awesome because I am using a touch screen, so hopefully it goes well. So if I drop down a line here and then make my T, here's my T-chart. Over here, I have the reactants, and over here, I have the products because the arrow is pointing to the products and away from the reactants. So step one is to list the atoms that you see. All right, first we see hydrogen, so I'm going to put down H, and I see oxygen, so I'm going to put down an O. Now you got to ask yourself, how many hydrogens do I see? I see 2 because of the subscript saying that there's 2 hydrogens there, so I'm going to put a 2 here. And only 1 oxygen because there's no subscript there, which means that there's only 1 of it. So I'm just saying that there's 2 hydrogens and 1 oxygen. Now on the other side, you're always going to have the same elements because, like I said, you cannot create or destroy anything. So you're going to have exactly the same on the products and the reactants. So I'm going to put down an H because that's here. And put down an O because that's here. Now I have 2 hydrogens and 2 oxygens. All right, so are these equal? If they are equal, it's balanced. If they are not, it is not. So 2 and 2, got 2 here and 2 here. That's balanced. However, you only have 1 here and 2 there. That's not equal. So this is not balanced. So this equation is not balanced. The equation is not balanced. All right, so in here, you're going to put not balanced. So speaking of balanced equations, here's what they are. Is when the amount of atoms in the reactants is the same as the products. So I did this drop down line again, and you can see in here that I added 2 coefficients. I added one with the oxygen in the reactants, and I added one with the products and the water molecule. What that does is that changes the total number of each atom and will make them equal on both sides of the equation. So you see you have 1 carbon there, and you have 1 carbon on the product side as well. You have 4 hydrogens and 4 oxygens on the reactant side, and you also have 4 of each on the product side. So you can do 2 that are with the carbon, so that's 2 makes 2 oxygens, and then 2 times the 1 makes another 2 for a total of 4. So make sure you understand that it's the total number of oxygens, not just the ones that are bonded separately. So let's go ahead and check this out. So same deal. I'm going to make a T-chart, and we're just going to count here. So on this one, notice how the arrow is pointing to the right. That makes this my reactants and this my products. So I still have hydrogen and oxygen. Oops. So this 2 says that you're multiplying this by 2. So you have 2 sets of H2O. So 2 times 2 sets makes 4 hydrogens. 2 times 1 set of oxygen makes 2. We'll go to the other side of the equation now. We have hydrogen again. You have oxygen again. So again, here's that coefficient. Remember, that means 2 of this whole thing. So if I have two 2s, let's say it again. If I have 2 H2s, then I make a total of 4 hydrogens, and this is by itself, so it's only 2. So now let's see if they match. 4 and 4, that's a match. 2 and 2, that's a match. So this equation is balanced. So in your notes, you'll type out balance. Okay, so now this is the part of the Nearpod where it changes up a little bit. So it's either going to be moving towards the first one I'm going to do is going to be with the general ed, and the second example I do is going to be the AA class. All right, so it's gonna be, all right. So this first one is for the regular classes. So if you were in AA, this is not for you. You can fast forward the video until I get to the notes that match yours. So down here, it should look like this. All right, so count the number of atoms in the products and reactants. Don't worry about balancing right now. So this is for the general ed. We look at this. If you double click on it, you'll see this pop up. Okay, so what I want you to do in the blue boxes is put the reactants here and how much there are. So in the reactants, I see a magnesium, and there's only one magnesium because there's nothing else on this side and there's no subscripts. So I'm only going to put a 1. On the next one, I have phosphorus, P, and you can see that I have a 4 in the subscript. So that's going to give me 4 of these. Now I'm going to go over to the side. There's magnesium again, and there's 3 of them. And I have phosphorus, and there's 2 of them. All right, so now you ask yourself, are these numbers all equal? The answer is no, they're not. So this equation is not balanced, and we'd have to add coefficients in these yellow spots, which we're going to do tomorrow, that will help them become equal. And that's where we start playing the number game. So hit save and close. And then this is not balanced. Okay, so now for the AA assignment, if you go all the way to the bottom, and we're going to be here. We're going to say rules for balancing. I'm going to zoom in a little bit. So rules for balancing is 1, draw a T-chart. 2, list the elements that are represented on both sides. Okay, so do that here. All right, so magnesium, there's 1. Phosphorus, there's 4. On this side, we have magnesium again. There's 3. And then we have phosphorus, it's 2. All right, so far so good. I'm gonna go back over here. All right, next it says, choose one atom to begin balancing by adjusting the coefficients of the element you chose so that they are equal on both sides. Then recount the total number of atoms on each side of the equation because they could change the whole thing. So let's start with a number. Look, my suggestion for you is to look for numbers that go into each other evenly, easily. So 3 and 1, yeah, you can multiply this by 3, all right? But that doesn't really solve much, and it's not an even number. But 2 and 4, 2 already goes into 4. So let's start there. So that's an indicator of where you want to start. All right. And remember, this is, like I said, this is a game. All right. So think of this like a number game. Think of it like a moving scale. When you slide some to one side, you're going to tilt the other side too. and your whole game is to try to get them all to be equal. And it gets kind of fun when you start getting the hang of it. So you start on the lower side here. So with P, what do you have to multiply 2 by in order to get to 4? All right, the answer is 2. So where you find P, the compound you find P in up at the top, you have to multiply the whole thing by 2. So I'm going to put a 2 in front there. So 2 times 2 would make this 4. However, since magnesium and phosphorus are bonded together, you're also going to change your number of magnesium because you can't change one without changing the other when you put coefficients in. So 2 groups of 3 makes 6. Okay, so now you've balanced these two. That's good. So now you have to balance these two. And luckily, that's easy to do because 1 times what number equals 6? You should be saying 6. 1 times 6 is 6. So that means 6 magnesium would make this number also a 6. So now your magnesium and phosphorus on both sides of the equation are equal, and this is balanced. Now, if you have a blank here, that just means there's a 1. All right, because you only need one of it. But we don't write down ones, we leave them alone. So this should be your final equation. Hit save and close. All right, so I'm totally understanding that some of you guys might be confused by this. Here's a couple things you can do. One, rewatch this video, go back and look at anything you might have missed. Two, check out other videos on YouTube of people balancing equations. They might do a better job than me, and it might be beneficial to you to watch somebody else do it. Maybe it's better for you. That will help out a lot. Three, come back tomorrow. We're going to do a lot of practice on this. It will start slow and it will be painful, but I promise you in 2 or 3 days, you'll be really good at this as long as you keep trying. This is a game, so you're going to go back and forth a lot, all right? But this is something that's very important for you to learn later in chemistry. All right, so submit this when you're done. Reach out to me if you have any questions, and I will see you guys in class.